In this video, we'll discuss linear functions. Now, a linear function is a function that when it is graphed forms a line. We talk about this in two forms. First is the standard form, which is ax plus by equals c. This form is great when we're trying to find the x and y intercept. In other words, where the line crosses the x and y axis. To do so, we set one variable equal to 0 and we solve for the other. For example, say we want to find the x and y intercept of 4x minus 5y equals 12. To find the x-intercept, we will set y equal to 0. So 4x minus 5 times 0 equals 12. This term here will then go to 0, leaving us with 4x equaling 12, or x equals 3. This means that it crosses the x-axis at 3, 0. To do the y-intercept, we will now set x equal to 0. So that becomes 4 times 0 minus 5y equals 12. This term again becomes 0, leaving us with negative 5y equals 12, or y equaling negative 2 2/5. So that ordered pair would be the x value of 0 and the y value of negative 2 2/5. And that's where it crosses the y-axis. If I graphed, I could see these 2 points specifically, at 0, negative 2 2/5, and then at 3, 0. The other form we talk about is the slope-intercept form. This is great for graphing. And the reason is because it gives us our slope and our y-intercept. If we know those two pieces of information, we can graph just about any line. Now let's start with that idea of the slope. This represents the steepness of a line. And you'll hear conversations about the types of slope. For example, a positive slope would be a line which rises as it goes from left to right. A negative slope would lower as it goes from left to right. An undefined slope is going to happen when your x values are the same in the two ordered pairs that you may be given. And we would say the line's equation would be x equals 2 in this case because that's the x value that is the same. If you hear of zero slope, this is a horizontal line, and this occurs when the y values are the same. And in this case, we'd say that this line is y equals 2 because that is the y value for which it goes through. Now, how do we determine slope? If we have 2 points, we know that we can take the second point and subtract the first point. It's the change in our y's divided by the change in our x's, and that gives us the slope. So let's look at an example. Say we have the ordered pairs 3, 4, and 1, negative 2, and we want to know what's the slope of the line that goes through them. So here is that line graphed, negative 3, 4, and 1, negative 2. So I would use my slope formula, which is the change in my y's divided by the change in my x's. So if I say the second ordered pair is here, I'm going to take my y value, negative 2, and subtract my y value from the first ordered pair, positive 4. I'm then going to take my x value from the second ordered pair, 1, and the y and x value from the first ordered pair, and subtract it. Now I need to pay very close attention to my negatives here, because I'll have negative 2 minus 4 is negative 6, but 1 minus negative 3 is positive 4. And I would simplify this slope to become negative 3/2. And I can check this. If I do that, I would go down 3 to the right 2, down 3 to the right 2, and that keeps going on forever and ever for that line. But however, that negative 6/4 also works. I can go down 6 and over 4, and it still gives me the same slope. So the simplified version works as well as the original expression. Now, if I want to actually graph a line with 2 points, I start with that slope. Then I'm going to take my slope and either of the 2 points to determine the y-intercept using the slope-intercept form of a line. Then I will take my slope and my y-intercept and rewrite the equation using slope-intercept form. So let's actually put this to practice. So say we have the ordered pairs negative 2, 3 and 2, 1, and we want to find the equation of that line. First thing we do is determine its slope. So I'm going to take the change of my y's over the change in my x's. 1 minus 3, 2 minus negative 2. And remember, minus negative makes it plus positive. So I have negative 2/4, and I'll simplify that to negative 1/2. Now, Step 2, I'm going to take my slope and one of these two ordered pairs, doesn't matter which one, I'm going to use the positive one just because it's a little bit easier to work with. And I'm going to substitute these values in. This is my slope, the m, and this is an x and a y value, and I can solve then for the y-intercept, i.e. b. So y equals mx plus b. Negative 1/2 times 2 is negative 1. I add 1 to both sides so that the b value is 2. The last thing I have to do is say that I have my slope of negative 1/2, my y-intercept of 2, and I'm going to write that in the equation of the line. So I'm going to replace the slope and the y-intercept and say that this equation is y equals negative 1/2 x plus 2. Now if I want to graph that line that I just created, I'm going to start with that y-intercept where it crosses the y-axis, so that's 0, the b value, and then I'm going to use that slope to create a second point. In between any 2 points is always a line that I can draw. So let's go back to the equation we just made. Y equals negative 1/2 x plus 2. I start with my y-intercept, 0, 2. Plot that on my coordinate plane. Now I'm going to use that slope of negative 1/2. I go down 1 and to the right 2, and it puts a second point. Between these 2 points is a line. And if I go in either direction, down 1 over 2, if I go back 2 up 1, that's the same thing. It's a negative 2. It's always down 2 over, or down 1 over 2 every single time. So I know this is the correct line. Now within lines, we also have parallel and perpendicular lines. If 2 distinct lines are parallel, that means their slopes are equal. If they're perpendicular, their slopes are opposite reciprocals. That means that I would take my slope, I would think if it's a whole number, I'd put it over 1, I'd flip it over and give it the opposite sign. So a negative to a positive or a positive to a negative. That's what it would take to be perpendicular. So let's look at some examples. Are these two lines parallel, perpendicular, or neither? Well, let's check out their slopes. That's a positive 2/3 and a positive 2/3, and they are distinct lines because they have different y-intercepts, so they are parallel to one another. And if I graph them, I could see this. Here I can see that they're rising 2 and running 3 every single time. Now, how about this one? Here, I'm not in slope-intercept form. It's a little harder to figure this out. So what I do is I'm going to change both of these equations of lines into slope-intercept form from their standard form. So let's start with the first one. I'm going to subtract 2x from both sides so I can get y by itself. And now instead of having 1y, I have 4y. So I need to divide all three terms by 4. 4y divided by 4 is y. Negative 2 divided by 4 can simplify to negative 1/2. And 4 divided by 4 is positive 1. Now let's take the second line. Y minus 2x equals 3. I'm going to add 2x to both sides, and that will leave me with y equals 2x plus 3. Now I want to compare the two slopes. This is negative 1/2. This is positive 2. That's like positive 2 over 1. They are reciprocals, and one is positive and the other is negative. So yes, they are perpendicular. And if I graph them, I could see that where they intersect is a 90-degree angle.